Okay, for the ocean circulation lab, I have a 10-gallon aquarium here, and then I've got a pot of boiling hot water, just got it to boil. There's some food coloring and a container of ice water. This water in the aquarium has been sitting for about 10 minutes, so there's no stirring or mixing or circulation going on in it at all. Oops, sorry about that. And what I want to do is end up setting up an ocean current. And how I'm going to do that is I'm going to take this ice water and carefully place it in the aquarium on one side, and then this is the very, very hot water. Pour some of that into this other beaker. You can see it's steamy hot, and carefully place that in the other end of the aquarium. So now from the top you can see that I have hot water on the left and cold water on the right. And what happens is the water begins to circulate in the aquarium. And to be able to see that circulation, sorry about that, just dropped you there for a second. I have some food coloring here, and I'm going to suck up some of this blue food coloring and then place like a puddle of it in the bottom of the aquarium as carefully as I can near this hot water. There's a good sized glob of it here. I'm also going to place some in the right side of the aquarium by the very, very cold water right here. And we're going to watch and see what happens. So these puddles of water are going to begin to move. And here you can already see that on the side of the aquarium with the hot water, the food coloring has already moved up the side of the beaker and is starting to move across the top of the water. And for the cold water side, that puddle of food coloring is beginning to move to the left. So we'll just watch this run for a little while, but basically as water is warmed up, it becomes buoyant and will rise up. That's what you see happening on the left. And in order for that water to rise up on the left, there has to be some water to replace it on the right. And the water that replaces it on the right is the water with the food coloring that's cold that I put in on the right hand side. So you can see here that there's food coloring moving across the top of the tank from left to right, and cold water moving from right to left along the bottom of the tank. And it turns out that water will end up mixing up here in just a little bit. So as some of the food coloring gets to the right hand side of the tank, it'll end up dropping down. Here you can see it begin to leave the surface of the water and go down a little bit. So this is a view from the side. A view from the top looks kind of like this. You can see that the water that moved from the right hand side of the tank to the left hand side of the tank on the bottom moved across pretty quickly. And then there's some food coloring on the top, and that's the smear that's here on the this part right here. That's water, that's food coloring that's on the top of the water. All this food coloring here is food coloring that's on the bottom of the water. So the stuff that's on the top is warm, stuff that's on the bottom is cool. And you'll see that we end up with some stirring and some mixing. It's not exactly orderly and patterned, but nonetheless, the water in that tank is stirring and mixing. It's heading across the bottom on the right, from the right to the left, and then moving on the top from the left to the right in that direction. So you end up with a general circulation pattern in the tank. So that's what students see whenever they see it live here in class. I'll just move it around a little bit for different angles so you can see the effect that it has. Drop it down a little bit again, like that. It gives you a good three-dimensional view of the direction that the food coloring is having. So in our world's oceans, there are differences in temperature for the water, and as a result of that difference in temperature, that can cause ocean currents to happen.